Good morning everyone. Welcome to second lecture of atomic structure. So today we are going to learn Millikan oil drop experiment, because in the last class we have learned about the cathode ray experiment done by J.J. Thomson. I hope you all have watched that previous lecture. So from that J.J. Thomson has discovered the charge by mass ratio. Okay, so now we will see the charge of an electron discovered by Millikan with his Millikan oil drop experiment. So what he has done, he has taken one container, and in this container he has placed, you can see here, positive charge plate and one negative charge plate. Okay, and here he has used an atomizer. Atomizer is just like the thing which we used which spray the small droplets of water, or any if you will put oil, it will spray small droplets of oil like this. And one more thing, what he has used X-ray sources. You can see here X-ray sources he has used, and one microscope. So what was his experiment? You can see here he has done one small hole. You can see here one small hole in the positive charge plate. Okay, so now what he has done, he has taken here oil in this atomizer. He has taken oil, okay, and he has sprayed oil here in this place. And what he has done, he has make the size of this hole in such a way that only one drop can pass at a time. Okay, now since after when he has started this experiment, one oil drop from here it has reached here. Since you can now see that since this oil drop, and here some gases are present. Okay, and here he has placed some gases. So since X-ray sources was passed in this area, so what this X-ray has done, he has, you can see here, suppose this is a gaseous atom, and when X-ray has hit this gaseous atom, what he has done, X-ray has throw out the electron from this gaseous atom. Now this electron, which so many electron this gases and this X-ray sources has, in this way X-ray sources has emitted so many electron. So the electron was roaming in this area. So this oil drop, some of the electron has get attached to this oil drop. So but we don't know how much electron has been attached to this oil drop. So we take this as Ne. Suppose this is our oil drop, and this oil drop is carrying n number of electrons. Okay, this oil drop is carrying, suppose, n number of electrons. Now as we all know that this oil drop will come to downside due to gravity, or you can say that mg, due to mg it is coming downward. So but what Millikan has done did, he has, since you can see here this is a negative charge plate, and this oil drop is carrying what? Electron, means this is also negative charge. Since this is a negative charge plate and this oil drop is carrying electron, so this is also a negative charge plate. So what Millikan has done, he has increased the charge or negative charge of this plate. So since you can see he has increased the negative charge of this plate, now this plate is repelling this oil drop. Okay, so if he is repelling with this QE charge, suppose, okay, charge into electric field. Okay, so one time will come when this mg will be equal to this QE. Okay, so by this when this mg will become equal to this QE, this oil drop will stay here, or suppose here or anywhere, means he will stay in the middle, because from both the side he is getting equal force, so it will stay in the middle. So now in this way Millikan has calculated the Q charge. Okay, so whenever he was calculating the charge, what he has got, every time he was getting an integral multiple. Means what? First time he has got, suppose 1.602 into 10 to the power minus 19 column. So every time he was measuring the value of Q, he was getting like this. Sometime it was getting 2 into 1.602 into 10 to the power 19 column, or sometimes he was getting 3 into 1.602 into 10 to the power minus 19 column, or sometimes he was getting 4 into 10 to the power 4 into 1.602 into 10 to the power 19 column. So he concluded that the charge which is present in the electron is this 1.602 into 10 to the power minus 19 column, which is minus in charge, negative charge. So in this way Millikan has find out the charge of the electron, which is 1.602 into 10 to the power 90 minus 19 column. I hope all of you have got this. Now next, after the discovery of electron, one question has came in everybody's mind, that as we all know that atom is what? Atom is neutral. But with the J.J. Thomson experiment, we have got that atom is in atom there is a negative charge called electron. But when we are seeing as a whole, atom is showing neutral result. So there must be some positive charge in the atom. That is why with this negative and positive charge are balancing each other, and atom as a whole it is neutral. So this question arises in the mind of the scientist. So one scientist named Goldstein, he has done the one experiment. An experiment was same as that of the J.J. Thomson experiment, which you can see here, which you can see here, J.J. Thomson experiment. In the last class we have done this experiment. So exactly the same thing J.J. Thomson has conducted in his lab, but one small changes, he had made one small changes. Okay, what is the change? You can see here. Before that, J.J. Thomson has used like this electrode. No? You can see there in the previous lecture you have seen. So you can see here. Here he has used like this electrode. No? Electrode. But Goldstein, what he has done, he has used this type of perforated, which we called it perforated cathode. Okay, so this plate has a small hole. Okay, you can see here this plate has small hole, and everything was same as it is. He has connected this with a vacuum pump, and after that this one is connected to a negative charge and this one is connected to a positive charge. Okay, and the gases, so many times he has first of all he has used helium gas, and after that argon gas, and at last he has used hydrogen gas. So we will discuss about it. So what happened here is that you can see here, suppose this is our, you can see here, okay, you can see here, suppose this is a gaseous atom. Okay, this is the gaseous atom, and this side is negative side and this side is positive side. As we all know from the Thomson experiment that the cathode ray travel from negative to positive side. So since this cathode ray is carrying a negative charge, okay, so when this negative charge is striking this neutral gaseous atom, okay, when this negative charge striking this neutral gaseous atom, what this negative charge is doing, it is throwing out electrons from this neutral gaseous atom. Okay, this negative charge, what he is doing, he is just throwing out this electrons from this neutral charge gaseous atom. Now this gaseous atom has become what? Positive charge, because negative charge already electron has been thrown out from this gaseous atom. So now this, since this is a positive charge, it will travel where? This side, cathode side, because it is a negative. So it will travel which side? This side. So most of the time, so many gases was there. Most of the time, some of the gases came and strike here, 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 and there, like this. But some of the gases which has come in this region, the region where the hole is there, you can see the hole. So in the whole region, that was that positive charge has crossed this plate, just like you can see like this. Suppose this is the hole, one hole, and suppose this positive charge is coming from here. Okay, so this positive charge has directly passed from this hole and come out here like this. Okay, so what Goldstein had observed, after some times he is seeing a yellow light here in this portion. Okay, so this light which he was observing here, he called this rays as anode rays. Okay, an anode ray. And this anode ray, since it is generating from where? Anode to cathode. So that is why he given its name as anode ray. And he told that the charge of this anode will be exactly as same as the charge of the electron, but it will be of positive charge, which is plus 1.602 into 10 to the power minus 19 coulomb. So since he was using here hydrogen gas, as we all know that hydrogen is atomic number is what? Atomic number is 1, and it carry one proton and one electron. Okay, so since it is carrying one proton, so it is easy to calculate the mass of the proton of hydrogen. So he calculated the mass, which came to be 1.66 into 10 to the power minus 27 kg, or we can also say that 1.66 into 10 to the power minus 24 gram, or 1.0076 AMU, atomic mass unit. Okay, so this was all about the discovery of proton by Goldstein. Now, after the discovery of electron and proton and charge on electron and charge on proton, one scientist named James Chadwick, okay, James Chadwick, in 1932 he has done one experiment, and with his experiment we have got one more thing, or we can say that one more thing in an atom, which is neutron. Okay, so what was his experiment? We will see that. So James Chadwick has discovered neutron. So how he has done his experiment, we can say like we can see here. He has used alpha particle. Okay, suppose this is the sources of alpha particle. Okay, alpha particle, and he has bombarded this alpha particle on a beryllium sheet, thin sheet of beryllium. He has taken a very thin sheet of beryllium. Okay, he has taken very thin sheet of beryllium, and he bombarded this alpha particles in this region. So since this is carrying a positive charge, this alpha particle carrying a positive charge, so when it strikes this beryllium sheet, it's through it has ejected some particles from here. Okay, to some particle from here, and when he detected this particle, when he has seen the charge of this particle, he found out to be neutral. It was carrying no charge. Okay, and plus one more thing, the mass was exactly same, means, or we can say that approximately same as that of proton. So he called this particle as neutron. Okay, so neutron, what he concluded, that neutron, it is inside atom and it carry no charge, but its mass is exactly same as that of proton. So in this way he discovered, James Chadwick discovered neutron. Now next, after the discovery of electron, protons and neutrons, the thing, every scientist has started to talk about the arrangement of this electron, proton and neutron in an atom. Okay, all of our varied, or all of our searching how, or all of our questioning how these particles are arranged in an atom, how electrons are arranged, how protons are arranged, and how neutrons are arranged in an electron in an atom. So since J.J. Thomson has done so much so much on this discovery of electron, so all of them, so J.J. Thomson has given one you can say that one model. Okay, J.J. Thomson has given one model, and that model, he called that model as Plum pudding model. Okay, J.J. Thomson in 1898 he has given one model of atom, that how in an atom electron, proton and neutron is situated, or we can say that how it is located. So he has given one model which is called Plum pudding model in 1898. So you can see, or it is in some book you can find that watermelon model. Okay, so what he has told about this model, that atom is like this. Okay, suppose this is an atom, what he has told, suppose this is an atom, and all this part, suppose we take the example of watermelon. All of you have seen the watermelon, right? So in this watermelon you can see that reddish part here, no? In this all places you can see the reddish part, red part, no? Red part, and in the between the red part you can see the seeds. Okay, you can see the seeds. So J.J. Thomson, what he told that whatever the reddish part is there in the watermelon, that is the proton. Okay, and the seed, which is the seed is electron. Okay, I hope all of you are understanding. He told that atom is a sphere in which positive charge is uniformly distributed. Okay, what he says, atom is a sphere, okay, and the positive charge is uniformly distributed. And number two, what he's told, and electrons are embedded in it. Electrons are embedded in it. So this was one more thing. We can take the example that watermelon, the reddish part of the watermelon, he called that the reddish part is proton, and the seeds, the black seeds, which is an electron. So this was the model, Plum pudding model. So these three things we have learned today. So let us recall everything. So discovery of proton by Goldstein. So regarding proton, what we can say, that depending on the nature of the gas taken in discharge tube, okay, in proton, in this experiment, depending upon the nature of the gas taken in a discharge tube, anode or anode rays are simply a positive charge gaseous ion. Okay, and the charge by mass ratio which we take now, that's like in the case of electron we have taken here also, charge by mass ratio, this ratio of proton, okay, um, is smaller than that of the cathode ray. It will be smaller than that of the cathode ray. Okay. Or so this was all about the discovery of proton. And regarding this James Chadwick discovery of neutron, James Chadwick, what he has done, he has bombarded the thin sheets of beryllium with an alpha particles, and a neutral particles having a mass slightly greater than that of the proton was emitted. Okay, so in this James Chadwick discovery of neutron, we can say we can take one equation also, just like this: beryllium 9 4 plus helium 4 2, it will give what? Carbon 12 6 plus 1 0 neutron. So this was the equation regarding the neutron, discovery of neutron. And next, that is Thomson plum pudding model, as we all know, which is also called a watermelon model. So what he told, that atom is a sphere in which positive charge is uniformly distributed and electrons are embedded in the sphere. But this model, what the J.J. Thomson has given, this model has failed in so many respects. Okay, so we will see what was the drawback of the we can say the drawback of the plum pudding model. So number one drawback was that if we are considering the mass to be evenly spread across the atom, then we can say that in this if you are taking the example of this, so if he told that positive charge is spread across the means positive charge is uniformly distributed here, then he doesn't told anything about the movement of the electrons. He told that electrons are just embedded like a watermelon. In a watermelon, the seeds are embedded. In the same way, these electrons are embedded. He has not told anything about the movement of the electron. Okay, and eventually it does not explain the stability of this atom. Means he has not told anything about the stability of the atom. And number two, he just told that electrons are embedded and electron doesn't move. Okay, movement of electrons, we can say like this: he does not he has not told anything on the movement of the electrons, and number two, stability of the atom. So this was the drawback of the J.J. Thomson plum pudding model. So in the next class we will see Rutherford alpha scattering experiment. Okay.